Hi physics enthusiasts, welcome virtually to the PACE Labs in the School of Physics and Astronomy. Let me briefly introduce myself. I'm Bernhard Müller. I'm working here as an astrophysicist, and my expertise are stars and how gravity holds stars together and sometimes makes those stars collapse to neutron stars or black holes. Now today I'm going to show you some way of cheating gravity. We know what gravity normally does, right? Gravity on Earth pulls everything to the ground. So we can try that here with those cylinders of different materials in this plastic tube here. You see, regardless of what material we have, all those cylinders nicely make their way down. And they actually fall down, everything else being equal, factors like air resistance being equal, they fall down with precisely the same speed. That's one thing that Galileo discovered a few centuries ago. But it actually turns out that this is not always the case. Now let's do this experiment again in a cylinder, in a tube that is composed not of plastic, but of copper. So let's try this with our first metal cylinder here. That does exactly what we expect it to do. Now let's try with this one. All right, let it go. And we hear no bang for a long time. And the whole cylinder, whole thing is just stuck in here for a long time, falls down very slowly. Let's try that again. Put it in here, and it doesn't hit the bottom until about, well, not even now, still waiting, only until now. So it falls down very slowly. Why is that the case? Well, you might imagine that I'm cheating a little bit, so there is something special apparently about this cylinder here. What might that be? Well, you could guess whenever you want to stop something from moving, you use something that is magnetic. And indeed, that is what we've done. So this cylinder is magnetic. But there is one problem here with that explanation. So if you believe that this copper tube here was magnetic, then that might explain why a magnet is almost stuck. But is it magnetic? Let's try. So the copper tube is perfectly non-magnetic. So how can we explain this? Well, as I'm letting this slowly slide to the ground once again, I can explain what's going on. So what actually happens is that this thing doesn't fall down as it would just by gravity alone, not because of, well, there are magnetic forces involved there. But the point is not that copper is magnetic, but the point is that copper is electrically conducting. So what actually happens when I slide this magnet down through this copper tube is that as the magnet moves, it generates electrical current, and those electrical currents in turn then generate a magnetic field without actually permanently magnetizing the copper. And that magnetic field is configured such that the fall of this magnetic cylinder within the copper tube is slowed down. Now this is incidentally a principle that we also use when we construct generators, for example, or a principle that we sometimes use in order to brake locomotives by what is known as an induction brake. So just by sliding the magnet down the tube, I generate in the copper tube I generate electric currents. Those electric currents by themselves then generate a magnetic field, and that magnetic field is what slows down the magnet on its way down.